Hi, my name is Ruben Marroquin. I'm at the Fashion Institute of Technology's Textile Lab, where TDM and students from other majors learn about woven production. On this weaving demonstration, you'll learn some of the basic terminology used in weaving, the functions and parts of the loom, and efficiency developments in the weaving process. While the basic principles of weaving haven't changed much over the years, new materials and technologies available today make for a field of limitless possibilities. Developments in fibers, finishing techniques, and evolving mindsets are important factors to be considered by future textile designers. There are three basic weave families from which most other weaves stem: plain weave, twill weave, and satin weaves. Color and weave effects result when weaves are coordinated with color arrangements such as the houndstooth and the log cabin pattern. A blue warp woven with a yellow weft will produce a green effect on the fabric. The warp forms the basis for the woven fabric. It's a sequence of parallel yarn lengths referred to as ends. The warps are made in solid colors, striped arrangements with filament or spun yarns, depending on the desired effect. Hand weavers make their warps by hand, but most commonly, warping machines pull yarn directly off the cones and arrange each thread at an equal yardage. Even tension is imperative in the weaving process. It allows the second set of yarns in weaving, known as filling or weft, to glide across the shed without interruption. When warp threads are pulled up by harnesses or jacquard mechanisms, a shed results. Selected warp yarns are lifted evenly so the weft can traverse across the loom. The weft or filling yarns are wound onto spools placed within a shuttle that can be glided by hand or thrust by a power loom. Each new filling yarn interlaced across the warp is referred to as a pick. The power loom uses a steel hook that pulls the filling from one selvage to the opposite. It's used to weave fine fabrics. Air and water jet looms use propulsion to conduct the filling from one selvage to the next. The selvage is the lengthwise edge on each side of the woven fabric and is easily identified because of its change in appearance, usually having a different weave than the rest of the cloth. One way to determine whether a fabric was woven on a power loom is by looking at the fabric sides. If the fabric has fringes instead of a woven selvage, it's because the filling is cut at each turn by blades located at the edge of the loom's weaving area. The harnesses are moving frames within the loom containing heddles. The heddles are thin wires with a hole in the center through which the warp ends are inserted during the loom setup. Once the warp ends are threaded through the heddles, the harnesses are able to lift warps across the loom. Closer to the front of the loom, between the harnesses and the cloth beam, you'll find the beater, a swinging structure attached to the loom's sides, compressing each new row of filling woven across the warp. Operated by hand on floor looms and automated beater on power looms, it compacts each new pick at a preset rate. Located within the beater, the reed acts as a spacing device. Reeds are made of fine flat metal filaments through which the warp is organized. It helps open the shed as the beater swings back and forth and determines the cloth density and width. Depending on the woven structure of a determined fabric, the harnesses will lift different configurations of threads. The structure most commonly used is plain weave, based on the principle of opposites, where every other yarn alternates to create a shed exactly opposite to the previous one. There are many different types of looms. Early examples are found in ancient civilizations in the form of wooden frames and dowels. Warps were held taut by weights at the bottom of the loom or tied to trees and tensioned by straps attached to a reclining weaver. Weaving classes at F.I.T are taught with three main types of looms: structo, tabletop looms on 4 and 8 harnesses, which lift the shafts, another word for harness, by pressing on levers by hand. Maycomber floor looms lift the harnesses by stepping on treadles, each pedal connected to one or more shafts, and Dobby looms, operated by mechanical peg bars or computer interface. The draw loom wove elaborate weaving patterns. An additional worker situated on top of the loom selected the warp threads to be lifted while the weaver in front of it focused on the quality of the weave. The jacquard loom brought complexity and efficiency to the market. Improved warp selecting processes enabled weavers to produce patterns of highly detailed imagery at a faster pace. Jacquard looms are operated by power-driven machinery, while the weaving patterns and colorways are processed mechanically through punched pattern cards or electronically by computer programs. Jacquard looms operate without the use of harnesses. Controlled from a tower on top of the loom, fine cables lift individual ends across a larger repeating pattern, generating detailed imagery to photographic resolution, as well as contemporary variations on traditional designs. Computer programs have facilitated the processing of large amounts of information involved in woven production, and enable clear and instant communications with professionals at mills around the world. The images of three-dimensional simulations generated by weaving computer programs allow designers to foresee what different yarn qualities would look like woven together, envision whole collections, advertise and sell the product using these approximations before production begins. Once the prototypes are approved, the designs are sent to computer-operated loom systems at textile mills. Woven fabrics are used in apparel, interior furnishing, industrial and medical applications, as well as artistic practice. The cost of a woven textile is based on the weight and quality of the yarns used in making them. Dyeing, printing, and finishing techniques will also affect the cost of a given fabric on textile markets. The ancient craft of weaving directly relates to our present era in many ways. The pixels in our screens translate to stitches on a woven fabric when working on weaving computer programs. The over and under motion of yarns during the weaving process helped us understand and apply binary code, the basis for computers. Weaving drafts, the instructions to create or recreate a fabric, resemble musical notations and involve mathematical calculations. Like math, weaving is an exact science because a minor error can be consequential. However, weaving can be approached experimentally with artistic intent where mistakes lead to new ideas. Thanks for listening, and I hope you're inspired to learn more about woven production.